the change in one variable with respect to another. And when I'm saying change in one variable, for us it is x and y. So whatever change we are observing in y with respect to x, we present them in the form of the ratio, that is change in y, which is y2 minus y1 divided by x2 minus x1. So this ratio y2 minus y1 upon x2 minus x1 is actually, we have the change. This change in the language of mathematical analysis helps us in estimating a very important thing, which we call it as differentiation. The process is known as differentiation. I have already briefed you a brief history of differentiation. It was suggested by Newton because Newton wanted to prove his fourth law of gravitation, and that small law, which we can state within 8-10 seconds, Newton took 20 years to prove this law. And during this process of proving this law, he developed a whole branch of study which we call it as calculus, in which we have two parts: differential calculus and integral calculus. So we are moving into a new world of calculus, and I'm starting the first half. The first half here is, we call it as differentiation. So I'm opening my word file that will help you to understand it better. Yeah. So, uh, yeah. Is this word file visible to all of you?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes,
Okay.
sir.
Yes, sir.
So the process is, we call it as differentiation. What is this process? The process of knowing the difference in the value of y. That is, y changes from y2, from y1 to y2. This is the change in the value of y. With respect to what? With respect to x, which changes from x1 to x2. So if there is this type of change that we want to observe, we want to calculate this change, we can find it out with the help of what we call it as this, in simple language, we call it as differentiation. As you know, dear students, that every area, whatever we have discussed, starting from mathematical expressions and then function, and now we have entered into calculus, has its own language, has its own grammar, has its own style of writing, has its own terminology, has its own symbols. एंड यू नीड टू अंडरस्टैंड दैट सब्जेक्ट इन इट्स लैंग्वेज इटसेल्फ। आपको उस सब्जेक्ट को उसकी लैंग्वेज में समझना होता है, उसकी लैंग्वेज में लिखना होता है, उसकी अपनी एक ग्रामर होती है, उसकी अपनी एक एक्सप्रेशन होती है। कैलकुलस is also of the same type, especially when we are talking about differentiation. We have the same thing. Like if we have the function f, we have this function f, and I want to calculate the differentiation of this function. That is, I want to calculate the change in this function with respect to x. So, you know, we venture it like this one, fx. I want to calculate the change in this function. That is, for example, if this function f, now it is changing from x1 to f x2. This function changes from fx, is a function which is changing from fx1 to fx2 with respect to what? You know, it is dependent on x value. So with respect to x1 changing to x2. For example, let me cost function. We have a cost function. We have a cost function, and which is the function of x, which is the quantity. And we want to know the change in the value of cost. That is c change in the value of this one, x1, this cx1 to cx2 with respect to what? The change in the quantity from x1 to x2. What is the change that comes in the cost if you change the quantity? आप जानते हैं ये बड़ा कॉमन फिनोमेना है कि अगर हम क्वांटिटी को चेंज करेंगे तो कॉस्ट चेंज होगी। सेम सपोज करिए कि इफ दिस इज द प्रॉफिट, I want to know the change in the profit. So I want to foresee what is the change in the profit with respect to change in this one, fx px1 change in profit with the quantity that is px2. What difference it is? So either it is a cost, or it is a profit, or it is a revenue, or it is any other phenomena. We want to know the change with respect to the other variable. That is a important thing. The answer of all this question lies fundamentally in the process of differentiation, which was suggested by Newton and which is represented by the language dy by dx. So if I want to calculate this one, I can use this word df, df, right, with respect to dx. This is the expression. So if this is a cost function, I would write down dc with respect to dx. I want to calculate the profit, then this is dp with respect to dx. So you can see the style of writing. The moment I want to calculate the differentiation of the function fx, the differentiation will become df by dx. If this is the cost, this is dc by dx. If this is the profit, we call it as dp by dx. This is how we write the differentiation. अगर कहीं पर भी df by dx लिखा हुआ है तो वो उस बात का इंडिकेशन है that we are doing the differentiation. That is the symbol of doing it. Similarly, there is another way of writing it down. What we can do is fx is a function. This can also be noted like this one, f9. Now I can put here this, and I can put this spiral or comma, what you call it as. This actually is known as spiral, but we call it as, you can see it as comma. So f dash x जिसे हम कहते हैं. तो अगर मुझे यहाँ लिखना है, so what I can do, I can simply write it down. I can simply write down. अगर मुझे इसका differentiation note करना है, तो what I can do, I can add this prefix and then I put it this one. Similarly, if I am doing like this one, अगर मुझे इसको लिखना है ऐसे equal to, if I don't want to write d5 by it, then I can simply write p. I put it here this one and I can write it down. Okay. So अगर कोई function मेरे पास है, if I have a function f x like this one, I want to calculate the differentiation of this function. So differentiation is f, simply I will put it like this one. I keep it this, right, and then I put it like the same way. So I just wanted to show you fundamentally how do we write differentiation. And differentiation of fx will become f dash x. And we also call it as df by dx. Now, what does this differentiation represent? What meaning do we infer out of that? If fx is converted into f dash x, what does it give? What meaning it will give us to us? That is the point that I would like to discuss with all of you with the help of some 2-3 in meaning that can be understood from this. This is df. This is what we have. What meaning do we get out of it? Number one, what is the first meaning that we get out of it? Anybody out of you? What is the first meaning? अगर ये लिखा हुआ है आपके सामने, if this is the thing expression which is given, what is the first meaning that you will attach to this?
So slope of function f.
Rate of change of function fx with respect to y.
Simply in simple language, change. What it represents? It represents the change. Change in what? Change in fx. Change in fx. With respect to what? With respect to x. Always remember that you cannot write simply change in f or change in p or change in c. You always have to mention change with respect to what. Is it quantity? Is it time? Is it volume? Is it any other variable? So with respect to is very, very important. Number two, what does it represent? That somebody have rightly said, if I write in this way, अगर मैं इसकी definition लिखता हूँ, I already told you this is coming out to be y2 minus y1, right? And then I would put it in the bracket, one whole divided by x2 minus x1. So by definition, differentiation is this. You have in the numerator, you have the difference in the value of y, and in the denominator, you have the difference of the value of x2. So numerator, change in y, denominator, change in x. This is conceptually also known as slope of the tangent, slope of the line. So slope of the line at a particular point is also calculated with the help of the differentiation. So I will elaborate this concept later on कि ये slope किस line की बात हम कर रहे हैं and what does it give. So slope definitely gives us the change, but pictorially, if you want to depict someone, pictorially, if you want to explain this thing, what change you are looking into that. So the picture of that change is represented with the help of the slope. So slope is nothing but it is a pictorial representation of the differentiation, which we call it as this one. So yeah, right. So once again, two important meaning that you can infer out of that is number one, if df by dx is given, this is change in f with respect to x, and number two, it is the slope of the line. Which line it is this? Now I will complete the slope of the tangent at a particular point. At a particular point. At a particular point. मैं word tangent नहीं use करना चाह रहा था ताकि I don't know how many of you can recall tangent. That is why I simply use the word line. So I will show you the picture and then you will understand what is the slope of the tangent. And this is a very important. The only purpose of putting slope here is that we should understand that pictorially, graphically, differentiation is the slope, and change in the value is the change in the slope. कैसे कैसे slope का angle बदल रहा है, change हो रहा है, that is a representation. So dy by dx or f dash x or y2 minus y1 upon x2 minus x1 is this, which we are showing in front of you, change in f with respect to s. This is what we have.
Okay. So just a query. So like, sir, you are calculating slope here. So this is meant for calculating the like demand and supply of the production in the market, or like it is for something else, or it's for calculating the manufacturing part.
Kritika, if I correctly understood your question, what you are asking is that you are talking that is this the same definition that you can apply in demand and function, demand and supply?
No, sir. I'm saying that here in this question we are calculating through differentiation. We are calculating the slope. So I mean to say whether like this is for this purpose is for calculating the manufacturing part, or like for calculating demand. Like in this year, we calculate this was like this is the difference between the production of two of a product in two different months or years, like something like that.
No, this definition is a general definition, right? You can apply this definition anywhere, irrespective of the nature of function, whether it is a demand, whether it is a supply, whether it is a cost, whether it is a revenue. The only requirement to apply this definition is that you should have a mathematical expression. You have a function fx. If you have a function, irrespective of anything, it can be a scientific function, it can be a biological function, it can be a mathematical function, it can be an engineering function, it can be a social science function, whatever. If you want to calculate the change in dependent variable with respect to change in independent variable, you can apply this definition. And slope is simply the slope of the tangent on that curve at a particular point. I will show you the diagram that will help you to understand it further.
Sure, sir. Sure, sir.
Now, definition wise, it seems very simple. It seems very simple that we can calculate the difference y2 minus y1, and then we'll take simply what is this? Simply it is y2 minus y1, y2 minus y1 on one side, and x2 minus x1, x2 minus x1 on the other side. It seems very simple, but you know, this is not so simple in the way, because the nature of function is very different. If the function is simple, y equal to a plus bx, then there is no problem. It's a simple linear function. But what would you say if this is not y equal to a plus bx? This is y equal to a plus bx whole to the power 10. If this function will become y equal to a plus bx whole to the power 10, which is quite obvious in business functions, in economics and financial functions, it's quite common. In that situation, calculating manually the value is very difficult. And moreover, this is not only one term. We can have different terms also. For example, we can put minus c and again x raised to the power minus 4 or minus 5. If this is a complicated function that we are handling, how do I calculate the differentiation? अगर आसान सा कोई function होता तो मैं y2 minus y1 upon x2 minus x1 करके निकाल लेता. But if this is the complicated situation that we are incurring, then in that case you cannot do it by simply following the definition of calculus, which is y2 minus y1 upon x2 minus x1. If this is the case, then the expert, the proponent of that method of calculus or differentiation has already come out with certain rules of differentiation. Certain rules of differentiation. So it's a high time that I will talk to you about something which we call it as the rules of differentiation. What are the key rules of the differentiation that we have? हमारे पास rules of differentiation क्या हैं? कैसे हम उन rules को apply करते हैं? I know some of you have already studied differentiation in your school days, in your 11th and 12th, or at graduation level, or at some other class. But my focus right now is not only for those. My focus is on those who are understanding the concept of differentiation for the very first time. So before I move ahead, any query from your side with regard to differentiation? कोई ऐसी clarification जो आप पूछना चाहते हैं या कोई और बात आप इसमें add करना चाहते हैं in the discussion? Or before I start talking about the rules of differentiation? Anybody out of you?
No, sir.
Okay. So let me move ahead and I will start talking about the differentiation. Actually, the rule of differentiation revolves around on the nature of function. What type of function you are handling, that decides your rule of differentiation. That decides your method of differentiation. That decides the formula of differentiation. Functions are of many types, as you know. It can take any form. It can take any shape. But there are certain functions, and because of this common in nature, we can segregate them. We can do it like this one. So I would like to start with some common type of function. Here the first function is f(x). Example, I'm writing it up. f(x) equal to, the first among them is the variable x, and then I will put it as raised to the power n. This function in the language, we simply call it as exponential function. For example, this is x raised to the power 4. This exponential function. So similarly, x raised to the power minus 10 or minus 19. So this function, like x to the power 4, x to the power 19, and so on and so forth, are known as exponential function. So if the first category of function under the category is exponential function, and if you want to calculate the differentiation of this, that is, I want to calculate the differentiation of this. So this is the function. I want to calculate the differentiation of this function, that is f this, and I want to calculate the differentiation of this. I will put it like this one, that is simply this, then differentiation of this function is equal to n into x raised to the power, yes, n minus 1. F dash x into n into x raised to the power n minus 1. This is the function that you have. This is the first rule that you have to remember. So agar exponential function hai and we want to calculate the derivative, n will come down, n into x n minus 1. So this is the small. Let me take with the help of an example. अगर मैं इसके example लेता हूँ, suppose करिए function है fx is given to you as given as x raised to the power 4, and you want to calculate the differentiation of this. So what would be the differentiation of this then? The differentiation of this will become
4x
4 into
X raised to the power
x raised to the power 4 minus 1, 4 minus 1. That is simply
4x cube.
4x. Okay, so this is the first category of function that we have, where we have the exponential one, n n is the exponent, and n can take any value. So one of the very commonest type of function which we encounter in business organization is this, which we call it as the fx. I will keep this rules of differentiation in the next page so that you can understand. So I hope the point is clear. Okay.
Yes, sir.
Yes, sir.
Let me take another function. Let me take another function. We have n. Another very common type of function that we encounter is not exponential. It's not another. We have the value, like we have the value 4, or we have the value like 5, or we have the value like 10, or we have the value like minus 13. If you have only one value, I hope you understand, this is known as constant function. We have the constant function. A constant function is, is this what?
So it will be 0.
I'll come to this point. So we have the constant function, and I want to calculate the derivative. Now somebody is responding that this is 0. Somebody saying, who is saying this is 0?
So Kritika. So when we differentiate it, it will be 0 because we do not have any value for x.
Just wait. Kritika, just wait. Kritika, a teacher is like a doctor. How much and when will the dose of a particular medicine given to the patient, who will decide? A doctor? So,
Sir, I can understand. I work as a lecturer. Actually, I work as a computer lecturer. I can understand that factor.
कितनी डोज कब और किस वक्त देनी है, this the doctor will decide, है ना? So I know that, but I'm just noting. So this is constant. Now somebody is saying that if you take the derivative of this, कोई कह रहा है कि if I take the derivative of this function, somebody is saying that it will comes out to be 0. अब मैं तो इस बात से एग्री नहीं करता कि ये 0. I have a different point of view. मैं तो कह रहा हूँ 1 होगा. Somebody is saying it is 0. मैं कह रहा हूँ 0 नहीं होगा, 1 होगा. How do you justify that? Will it be 0 or 1? Somebody is saying 0.
It will be 0. Sir, it will be 0.
Can anybody explain me?
Yes, sir. Sir, if you take
so we could say that differentiation is a change in value with respect to y, and constant's value does not change with any any change in y.
Yes. Right.
Sir, also,
Constant has a fixed value. If you put x,
we can also
anything, it
prove
will
it like
remain.
no, sir. From mathematically point of view, we can also put c into x to the power 0 and apply the above formula, and then we will get 0.
Right. So Hamad, Yatendra, Adil, your answer is absolutely right. That 1 is constant. So when it is constant, the slope will not change, and there is no change in the value. So when there is no change, it's quite obvious. No change in mathematically stand for 0. Then Hamad and Yatendra give a very apt answer to this, that even if you apply the first law, अगर हम पहला law apply करना चाहें, तो हम c की जगह क्या लिख सकते हैं? x raised to the power 0, because raised to the power 0 will become 1 or constant 0. So what he's saying that you can write c into x raised to the power 0, and then you apply rule number 1. So if you apply rule number 1, you will get 0. So absolutely right. Again, my focus is on those who are listening this discussion for the first time. आप ये ना सोचें कि आपको पता होना चाहिए, ऐसी कोई कंडीशन नहीं है. ये आपके लिए एक अपॉर्चुनिटी है. This is an opportunity for those who don't have a background of differentiation. Please seek clarification and don't feel that I am asking this small question. No, there is nothing small and large. अभी कोई एग्जाम नहीं हो रहा, अभी कोई टेस्ट नहीं हो रहा. हेसिटेशन वहां होना चाहिए कि जब आपका टेस्ट लिया जाए और आपकी परफॉर्मेंस अच्छी ना हो. अभी कोई हेसिटेशन नहीं है. You can raise queries, you can discuss. So anybody, any query? First two laws are clear to all of you?
Yes, sir.
Yes, sir.
Sir.
Let me quickly move to rule number 3, which is very, very important for us. Rule number 3 is scattering the third category of function, which is very, very common for us. What is that third category? Again, I'm taking this as x equal to. Now, quite, the very common function that we encounter is that we don't have exponential function only, or we don't have a constant function only. Rather than we have the combination 5 into x raised to the power 10. So we have the constant multiplied with the exponential function. तो ऐसा होता है कि ये जरूरी नहीं है कि हमें exponential function अलग मिलेगा या हमें constant function अलग मिलेगा, बल्कि ज्यादातर ये देखा गया है, और हमारे केस में बिजनेस ऑर्गेनाइजेशन में वी हैव द कॉम्बिनेशन. सो इफ दिस इज द कॉम्बिनेशन दैट वी आर टॉकिंग अबाउट, देन हाउ डू आई हैंडल दिस? हम कैसे इसको करेंगे? दैट्स एन इशू. What is the rule for that? So we have a clear-cut rule for that. C dot x raised to the power. This is the function, and I want to take the differentiation for this function. What I need to do is मुझे इसका differentiation निकालना है. So the differentiation of this function f dash x, if I want to calculate this f dash x, this is f dash x. So what I need to do, c will remain as it is, c will come out, it will remain as it is, and then we apply x raised to the power. The only thing left is this x raised to the power n. आप c को थोड़ी देर के लिए छुपा लीजिए, हाइड कर लीजिए, और फिर देखिए सिर्फ क्या रह गया, x raised to the power n. If it is x raised to the power n, you can apply rule number 1, and according to the rule number 1, this is n into x raised to the power, this is x raised to the power n minus 1. So c into n s is 1. This is what we have, the function that we have to calculate. So if I have, the very important thing, if I have this this function as, which I have just taken it, 5 into x raised to the power 10, right? And I want to calculate the differentiation for this. I want to calculate the differentiation. This will become 5 will remain as it is into, yes, 10 into x raised to the power 10 minus 1, that is 9.
9.
5 into 10, 50, and then we have x raised to the power 9. So this will become f into 10, 50, and x raised to the power 9. So this is simple rule number 1. Agar function exponential hoga, we can apply this rule. If the function is constant, no change in the value, f dash x is 0. But if the function is a combination of 1 and 2, then we have this rule that we need to apply. So these 3 fundamental rules of differentiation are very, very important for us to understand. Let me talk about the 4th rule, which is again equally important for us. 4th rule. 4th rule of differentiation is not about the nature of the function. Sometimes the function is of that type. Function हमारे पास क्या होता है, किस तरह से होता है? Function होता है ऐसे होता है, f x equal to, and we have 10x raised to the power 2, raised to the power 2 I'm saying f x, right? And I'm sorry, I'm just taking an example. Suppose we have the function x to the power 4, this one, plus plus 12. So this is the function. So we have the function fx. This is the function. And fx is x raised to the power 4 into 5 into x to the power 10 plus 12. This is the function that I am handling right now. How many terms do we have in this function? इस function में कितनी terms हैं?
3.
3 terms. X raised to the power 4, 5 into x to the power 10, and 12. So we have 3 terms in this function. I want to calculate the differentiation of this function. I want to know what I want to calculate. I want to calculate f, this value. I want to calculate dash. मुझे ये निकालना है. I want this. I want to calculate differentiation. So it is a combination of several terms. So in short, it is a combination of several functions. If this is the situation that we need to calculate, what we can have, what rule do we have? So we have a clear-cut rule for that. That if you have this type of function f, which I have just taken here, like this one, and you want to calculate the differentiation of this, then f dash x for this is this one. Is the combination of the various functions. That is, you take the differentiation of x4, that is we take the differentiation of of fx4, that is f x raised to the power, I'll just copy it here. This, then we have plus correct. Finally, this is what we have, that if you want to calculate this derivative, you have to take the derivative of each term separately. What is the rule? The rule is, if you want to calculate the derivative of this combination, आप तीन terms का derivative निकालना चाहते हैं, so the rule is that you have to take the derivative separately. Take the derivative of the first term, then put the sign. Take the derivative of the second term, put the sign, and then the derivative of the last term. I'm using the word sign, not plus, because if it is here plus, fine, we will put it here plus. If suppose here it is not plus, here it is minus, so I would put it here minus, not plus. So this is for plus and minus. You can simply, if it is plus and minus, you can apply this, plus minus here, and you can get it. So अगर मुझे इस expression का f derivative निकालना है, तो अब बताइए, if I want to calculate the differentiation of this, what would be the differentiation? What is the differentiation of the first term? Yes.
4x cube.
Cube.
4x cube.
First derivative is 4 dash x cube, right? Then
Yes, sir.
plus sign. Then we have 5 into 10
50x की power 9.
3x power 9.
50x 9.
raised to x raised to the power 9.
Minus 0.
And,
Minus 0.
and minus, we have the constant, which is 0. So 0, and then you keep it. So the final answer is this only. We have this 9. So final answer, derivative of this function will become this. So derivative of this function is this. So I will just keep it here. So with this example, this basic example, I just wanted to brief you the process of differentiation, which is nothing but we are calculating the change in the value of y with respect to x. Okay? We are calculating the change in the value of y with respect to x, and this is what we have right now in front of us. ये expressions हमारे पास आ रहे हैं. So quick reminder. As I have already discussed, we have the rule. How to calculate differentiation is basically based on the method of the nature of function. There can be any nature of function, but there are few nature which are very common to appear. Number one among them is the exponential one, x raised to the power n, and this is the rule n into x minus 1. Number two is the constant function, and the value of the constant differentiation is 0. Number three is a combination of first and two, that is constant multiplied with the exponential function, like if into x to the power 10, and I told you this one. Number four is when the expression or the function consists of many terms, especially plus and minus. I'm talking about only plus and minus. I'm not taking multiplication and division. I'm only taking plus and minus. So if the sign is plus and minus in between the expression, the rule says that you take the differentiation of the term separately and put the answer. Yes. Any doubt, any confusion? Or I will move to questions, and then, maybe you will get better clarity. Yes, Anna, you want to ask something?
No, sir, it's fine. I was seeing it, like now I got it. Like I got it. What's the point of you?
Okay. Anybody else? Feel free. Again, I'm repeating. Anything which is not clear, any small query is welcome. Okay. So let me start with the question, and then you will be in a better position to understand. Just 1 minute. Okay, so let me start with the question now. Okay.
Okay, sir.
Just give me.